Transform Data Generation Wizard module. Within Transform, the Data Generation Wizard is designed to be a guided workflow wizard. This tool allows you to create or extract new data from data that already exists in the session. The outcome of this tool will be data that you can view with other data in data analysis. The data analysis tools only allow data of a similar type to be analyzed together. For example, users can't compare seismic to well logs as one is a 3D cube and the other a log. But with the Data Generation Wizard, users can extract the seismic into a well log format to allow the data types to be the same to allow comparisons. This tool allows you to create or extract new data from data that already exists in the session's repository or database, regardless of the data format. Some common uses of the Data Generation Wizard are here at the bottom of the slide. You can create a pay indicator log from multiple cutoff criteria. You can create filtered well logs or seismic data for data extraction. You can merge values from multiple logs into a single log. You could smooth well logs into a similar resolution to be extracted seismic logs for data analysis and then later MvStats. You could also alias a well or zone attributes from 2 or more equivalent attributes with different names. These are just a few common uses, but I'm sure that you'll find some more that could be useful for your workflow. In addition to creating data from available data in the database, the Data Generation Wizard has additional tools that might be useful in workflows. First, merge seismic volumes. This workflow allows you to create a new seismic volume by merging 2 existing volumes. A base seismic volume is copied to an output volume and then overwritten by an injected volume. Use the settings to control where the ejecting volume will overwrite the base volume. Second, you can create tops from horizon scalars. Maybe you don't have logs in every well contained in your seismic survey, but you've mapped a seismic horizon. Use the wizard to extract well tops from horizon surfaces. It will take the wells in a well list and attempt to intersect each wellbore with a horizon surface. Where an intersection exists, a well top will be created from the wellbore. These are just a few more. I'm just trying to get you introduced to the Data Generation Wizard, but let's go ahead into Transform and take a look at this module. To access the Data Generation Wizard, click this button or choose Data, Generate New Data. Each workflow chosen on the left populates the panel on the right, and from top to bottom, the panel will explain the workflow outputs, and at the bottom, the panel shows the data needed to complete the workflow. Click through the different workflows on the left to see the right hand populate. If data happens to be missing to complete a workflow, it'll be highlighted with a red X to allow the user to resolve. Let's review a few. Let's review and transform the Data Generation Wizard, extract seismic to horizon surface properties. The extract seismic to horizon surface properties workflow in the Data Generation Wizard extracts from seismic volumes to horizon surfaces to produce a new horizon surface with those seismic properties. Users need previously interpreted time or depth horizons within the seismic volume for the extraction. There's a few extraction options, like RMS, mean, max, min, mode, sum absolute, number of troughs, number of peaks, instantaneous value, and ST peak frequency. You can see in the extraction type drop down below. In addition, there are options to perform the extraction above, below, or offset from the horizon surface. Let's go take a look in the tool. Open the Data Generation Wizard from the Generate button or Data, Extract New Data. Once open, choose the Extract Seismic to Horizon Surface Properties. This extraction allows users to view seismic properties against any other horizons and property maps generated. Users need a horizon surface and a seismic property to perform this workflow. Choose the workflow and click Next. At the top, working from left to right, choose the horizon surface to extract, and available seismic volumes associated with that surface will populate on the right. In this case, there are only time horizons and time volumes available, but this workflow can be completed with depth horizons and depth seismic as well. Choose the horizon and volume, click Add to push into the Lower Results tab. Add as many extractions to run at each time, each just needs a different name. In the Results panel, users can click the pencil to adjust the name of the generated horizon surface as well as the description. Users can also adjust the extraction type using the drop-down. Note that there are many to choose from. You can also extract a fixed time or depth window above, below, or offset to the surface. Once all your selections are complete, you can click Preview. This will allow you to just take a look at all the extractions that are going to happen and if any errors are going to occur. Click Apply to complete the extraction and review the successful processes. Users can find these newly generated horizon surface properties in the data tree under Geological features. Click Close in the Data Generation Wizard when complete. Transform Data Generation Wizard extracts seismic to well logs. The Extract Seismic to Well Logs workflow extracts from seismic volumes to well bores to produce a new seismic well log for each well bore. Users can set a vertical sampling window or set a window offset for the extraction. The interpolation options are as follows. 4 nearest points is the default, and according to plain view, you find the 4 closest points to the wellbore, assign a value to the intersection point on the horizon from the 4 nearest points using a sync interpolator, and then take the horizon values and use bilinear interpolation to assign a single value to the log. Next, you can do nearest neighbor interpolation. According to plan view, assign the value of the closest horizon point to that wellbore. Or instead of interpolation options, users can do statistical options including RMS, inverse distance squared, max, mean absolute, median, min, mode, and triangular. And in addition with the statistical options, you can choose sample cylinder dimension values that can be used. The radius can't be less than half the aerial diagonal width of a cell, and the half height can't be less than half the sample interval of the seismic. Let's go take a look at the tool. Would you like to analyze generated seismic volumes and properties with well logs? Here's how to do that. Open the Data Generation Wizard from Data, Generate Data, and choose Extract Seismic to Well Logs. Users need a seismic volume and a well list. Then they can choose the seismic parameters to extract. There is interpolation, 4 nearest traces, and nearest sample. Plus statistical parameters to choose such as RMS and many others, but this engages sample cylinder dimensions. Users need to input a radius, and this radius must be half diagonal of the cell of the seismic grid chosen. If you type in a number in the radius, it'll actually give you that number at the top of the screen. So once you make your selections at the top, a seismic volume, a well list, and different parameters for the extraction, click Add to populate the results panel at the bottom. You can rename the output well log name, adjust the start depth, sample rate, and description as necessary. Note, for this data generation wizard to conduct extractions on time data, each well must have a well time depth velocity model. See the velocity drop-down for those tools. Once you're happy with all your selections and different results that you're going to be extracting, click Apply. Once the extraction is complete, review the results log. View those that are successful and those that were not. In this case, the extractions that weren't successful was when the well wasn't in the seismic bin grid, or for this one well, there was no well velocity model present. View the results and click Close when complete. The data will now be viewable as a well log and can be used in well log data analysis. To look at the wells where the well time depth model reside, go to the data tree. Look in the well time depth model. If it is present, it will be listed. If not, like in the well with the error, there is nothing present. Additionally, you can view the well time depth models in the well header in the time depth pad. Transform Data Generation Wizard. Create geological zones from tops. To create geological zones from tops, users previously picked well tops and well top aliases to create a geological zone in wells. It also supports using the top or base of a well bore instead of the well top or an offset fixed distance from a well top location. Users need a top and base defined, and in addition to the zone creation, users can create MD and vertical attributes during the process. Options to define a zone can be the top style and the base style. So first, the top of the zone can be defined as a well top alias, top of the well bore, or defined fixed distance from a chosen value. The base style can be the base of a zone that can be a well top alias, base of a well bore, or defined fixed distance from a chosen value. Let's go take a look at the tool. The data generation wizard from the data generate data dropdown and choose create geological zones from tops. It's towards the bottom. This workflow allows users to create a wellbore interval geological zone along a wellbore defined between two well tops. It also supports the top or base of a wellbore instead of a well top, or can offset a fixed distance from a well top location. Choose a well top for the top and base of the zone. Users have the option to use a well top or a well top alias, and then you can limit it by a well list. Use the search bars at the bottom if needed. In the settings panel, there are choices for the zone name and a description. It's a good idea to list the well tops or alias used to make the zone here. Then click the top and base style drop-down menus. Here there are options for an offset or to use the top and base of a well in the absence of a top. Lastly, you can choose if attribute computations are desired within the checkboxes. Those are going to be down below. Click Add to populate the results section. Add as many combinations to create geological zones as desired, and click Apply when you're complete to actually run the process. Use the pencil to rename Once the geological zone creation is complete, the wizard generates a log to show which wells in the list have successfully created zones and those that were unsuccessful. Click on those with the conditions not met, and you can see in this case the top pick was not present in those wells, so a zone was not created. You can export this summary to CSV to get a list of the unsuccessful wells to investigate to create zones later. Click Close when done. The geological zone can be found in the wellbore interval section in the data tree. Use the bar at the bottom to search for your zone. Also, with a right click, users can view the geological zone and associated information in the well header of a well that the zone is present. Just take a look in the Zones tab and you'll see that zone and any associated attributes. Lastly, users can now use other zone scalar data generation wizard workflows with these newly created zones. You'll see them here, and then there's also some above in the Well Zone Scalars section. Transform Data Generation Wizard, create horizontal sections in a well. Open the Data Generation Wizard from the Data Generate Data dropdown and choose Create Horizontal Sections at the bottom. This workflow allows you to create a wellbore interval type horizon section based on a specific inclination. This section will be generated from the first point where it deviates to the end of the wellbore. First, choose a well list source, and then choose settings to create or create and overwrite if users are updating this process from a previous run. Click Add and verify the horizontal section name and any other properties, including the input inclination. You can create as many horizontal sections as you like, as long as each one of them has a different name. Click Apply to create the zones, and then once the horizontal section zone creation is complete, the wizard will generate a log to show which wells in the list have successfully created zones and those that were unsuccessful. The first list shows those that were successful, and then the ones that have that the conditions were not met, it's typically because they're not horizontal wells. So yeah, they didn't have the proper input inclination angle. Click Export Summary to CSV to get the list of unsuccessful wells for you to investigate further, and click Close when complete. The horizontal section zone can be found in the wellbore interval section in the data tree, or users can view the horizontal section zone and associated information in the well header of the wells in the zone that the zone is present in the Zones tab. So here you can see the zones and all the associated attributes that were generated. Lastly, users can now use other Zone Scalar data generation wizard actions with these newly created zones. Transform Data Generation Wizard extract various data to well or zone scalar. Once geological or horizontal zones have been created in your project, users have options to extract various attributes to zones or to the well. See Create Geological Zones or Create Horizontal Sections video help for more information on these workflows in the Data Generation Wizard. Let's review these well and zone scalar extraction options. First, you have Extract Horizon Surface to Zone Scalar, Seismic to Zone Scalar, and Well Logs to Zone Scalars. This will result in 1 point per zone for an extracted attribute. Extract Horizon Surface to the Well Scalar will result in 1 point per well for an extracted attribute. And you can see here I've highlighted the well and well zone scalar attribute extractions in the Data Generation Wizard. Let's go review a few of these workflows. Transform Data Generation Wizard, extract horizon surface to well scalar. The extraction of a horizon to a well scalar will produce one value for a well. Users can set how the horizons are statistically sampled and interpolated with the various options in the settings section. In addition, for the well scalar extraction, users can control how frequently the horizon is sampled over the interval using the sample increment parameter. The extraction options are as follows. Extract values along the horizon, so you can extract to the wellbore based on the property type of the horizon, such as depth, time, or an attribute that has been extracted to the horizon. Second, you can extract relative to the horizon. For one horizon, distances above the horizon are negative, below, or positive. When two horizons are used, Control-click to select the second horizon. Extraction creates a log with values that are representative of the relative distance of the wellbore between the two horizons. Before the well's measured depth MD passes the first horizon, the log's values are negative. Once the wellbore passes the first horizon, the log values are positive, always less than 1. Only depth horizons can be used, and statistical options cannot be used for this type of extraction. Next, you can look into the interpolation options. There are 4 nearest points, which is the default, which, according to Plan View, find the 4 closest points to the wellbore, assign a value to the intersection point on the horizon from the 4 nearest points using a sync interpolator. And then you take the horizon values and use bilinear interpolation to assign values to the log. Next, you could use nearest neighbor, which, according to Plan View, assign the value of the closest horizon point to the wellbore. There are also statistical options. You can see that in the drop down below, RMS, max, mean absolute, etc. Plus, you can have an option to note a radius around the wellbore for extraction. Define a circle such that the radius must be greater than 50% of the aerial diagonal width of the horizon mesh. The center of the circle will be over each wellbore location. Let's go take a look at the tool. Open the Data Generation Wizard, Data, Generate New Data, and choose Extract Horizon Surface to Well Scalars. This workflow allows users to extract horizon surface data to produce well scalars. Users can set how their horizon surfaces are sampled and interpolated with the various options. First, in the Sources panel, choose the horizon surface for extraction. There are options at the top to minimize the list for easier searching. Plus, users can choose extract along horizon surface or relative to horizon surface. And this one we're going to extract along the horizon surface. Next, choose a well list for the extraction to be made. Below in the settings panel, there are options for interpolation sampling options. 4 nearest points is the default, and then also there's nearest neighbor. Plus, additional statistical options are available that allow a radius in feet for the extraction around the wellbore. Choose desired sources and settings and click Add to populate the results panel. Users can have multiple results outputs and use the pencil to adjust the name and description of these outputs as necessary. Click Apply to run the extraction. Once complete, the data generation wizard will show a list of successful extractions and those of the conditions for extractions not met. You can click the Export Summary to CSV to get a list of all unsuccessful wells to investigate that extraction further. Click Close when complete. These extracted attributes can be found under the well Scalars in the data tree. You can use the search bar to find it. Or they can be found in the individual wells in their well header in the attribute folder. All of this data can be used in the Well Data Analysis MvStats workflow. Transform Data Generation Wizard extract horizon surface to a zone scalar. Extraction of a horizon to a zone scalar will produce one value for a zone. Users can set how the horizons are statistically sampled and interpolated with the various options in the settings section. In addition, for the zone scalar extraction, users can control how frequently the horizon is sampled over the interval using the sample increment parameter. There are two extraction options. Extract values along a horizon will result in extraction to the wellbore based on the property type of the horizon, such as depth, time, or an attribute that has been extracted to the horizon, and the second extraction option is relative to horizon. For one horizon, distances above the horizon are negative, below are positive, and when two horizons are used, Control-click to select the second horizon. The extraction will create a log with values that are representative of the relative distance of the wellbore between the two horizons. Before the well's measured depth, MD, passes the first horizon, the log's values are negative. Once the wellbore passes the first horizon, the log's values are positive, always less than 1. Only depth horizons can be used, and statistical options cannot be used for this option. The interpolation options are as follows. 4 nearest points is your default. According to plan view, it will find the 4 closest points to the wellbore, assign a value to the intersection point on the horizon from the 4 nearest points using a sync interpolator, and then take the horizon values and use bilinear interpolation to assign a single value to the well. Nearest neighbor, according to plan view, assign the value of the closest horizon point to the wellbore. And lastly, statistical options. There's RMS, max, mean, min, absolute, etc., plus options to note a radius around the wellbore for the extraction. Define a circle such that the radius must be greater than 50% of the aerial diagonal width of the horizon mesh. Center the circle over each wellbore location. And lastly, there are scalar sampling options. Let's go take a look at the tool. Open the Data Generation Wizard by clicking Data, Generate Data, and choose Extract Horizon Surface to Zone Scalars. It's towards the bottom. This workflow extracts from horizon surface to wellbore intervals to produce zone scalars. First, in the Sources panel, choose the horizon surface for extraction. There are options at the top to minimize the list for easier searching. Plus, users can choose to extract along horizon surface or relative to the horizon surface. Once you choose a horizon, next choose a wellbore interval for the extraction to be made. Refer to the video help on creating zone intervals for help creating zones. Next, choose a well list for extraction. In the Settings panel, there are many options. Interpolation options include 4 nearest points and nearest neighbor, plus statistical options that engage a search radius. In addition to surface sampling options, there are also scalar sampling options with the radius selections right below the surface sampling options. Choose desired sources and settings and click Add to populate the results panel. Users can have multiple result outputs, and notice the surface sampling and scalar sampling columns will populate. Use the pencil to adjust the name and description if necessary of any output scalar names and descriptions. Click Apply to run the extraction. The Data Generation Wizard upon completion will show a list of successful extractions and those of the conditions for the extractions were not met. Click Export Summary to CSV to get a list of the unsuccessful wells to investigate. Click Close when you're complete. These extracted attributes can be found under wellbore interval that the extraction was made in the data tree. In addition, you can search the well header in the Zones folder listed in the wellbore interval selected. Just right-click and view Edit Well Header and take a look at your Zones folder. You'll see all the zones and attributes associated with those zones in the folder. All of these data can be used in well data analysis and MvStats. Transform Data Generation Wizard extracts seismic to zone scalar. Extracting seismic along the wellbore will result in one value at the center of the wellbore or interval. There are two methods of interpolation: 4 nearest traces interpolation. A horizon slice is cut through the center of the wellbore or sample interval, and the application finds the 4 closest traces to each sample location. Then it assigns a value to that intersection point of the horizontal slice and 4 traces using sync interpolation. Using the 4 values around the sample point, bilinear interpolation is used to assign a value to each sample location. Next, nearest neighbor interpolation. At each sample location, the application determines the seismic cell that calculates which of the 8 corners is closest to the sample location. The closest corner value is assigned to that sample. Note the graphics below. Next, there are 3 methods of sampling parameters for extraction: 2 using 4 nearest traces or nearest neighbor, and 1 using a user-defined cylinder. The sampling methods will take samples at specified sampling intervals along the wellbore or zone and calculate the RMS average of these points according to their extraction technique. Let's take a look at the 4 nearest traces or nearest neighbor. A sample at the center of the interval will take exactly that, a sample at the center of an interval. Or you can do uniform sampling interpolation. That will use a specified sampling interval, and the samples will be distributed evenly in MD along the wellbore or interval for extraction. Only sample locations inside the volume will be used, and if the sample interval is less than the length of one of the wellbore intervals, a single sample location will be placed at the center of the wellbore interval. If it's time seismic, the wellbore must have a default well velocity. Lastly, user-defined cylinder. Sample at the center of the interval can also use sample cylinder dimension values. The radius can't be less than half the aerial diagonal width of a cell, and the half height can't be less than half the sample interval of the seismic. Note the graphics on the right to help you understand these different extraction sample options. Let's go take a look at the tool. Open the Data Generation Wizard by clicking Data, Generate Data, and choose Extract Seismic to Zone Scalars. This workflow extracts from seismic to wellbore intervals to produce zone scalars. First, in the Sources panel, choose Seismic Volume for extraction. Next, choose a wellbore interval for the extraction to be made. Refer to the video help on creating zone intervals for help creating these zones. Next, choose a well list for extraction. In the Settings panel, there are many options. Sample at the center of a wellbore interval and uniform sampling along the wellbore are the 2 main options. Let's start with sample at center of the wellbore interval. You have options for interpolation of 4 nearest traces or nearest neighbor, plus statistical options that engage the sample cylinder dimensions. If you hover over each one, it gives you a definition of each of the cylinder dimensions. In addition, there are options for uniform sampling along the wellbore. Choose desired sampling interval, interpolation with a statistical sample or a statistical sample with sample cylinder dimensions. Choose desired sources and settings and click Add to populate the results panel. Users can have multiple result outputs and use the pencil to adjust the name and descriptions if necessary in the results panel. Click Apply to run the extraction, and then you'll get an export summary of all the extractions that are made. For any errors that bounce back, click Export Summary to CSV to get a list of the unsuccessful wells to investigate, and click Close when complete. These extracted seismic attributes can be found under wellbore interval extraction was made in the data tree or in the well header in the zones folder listed in the wellbore interval selected. These data can be used in well data analysis and Transform Data Generation Wizard Extract Well Logs to Zone Scalar. The Extract Well Logs to Zone Scalars workflow allows you to extract summary data from well logs and save results as scalars assigned to a wellbore zone. Options include selecting well log alias or mnemonics for extraction and will result in one value per wellbore zone interval. The log sampling options are shown below. RMS, mean, mean absolute, median, min, max, mode, and sum are the options available. Let's go take a look at the tool. Open the Data Generation Wizard by clicking Data, Generate Data, and choose Extract Well Logs to Zone Scalars about 2/3 the way down the list. This workflow extracts from well logs to wellbore intervals to produce zone scalars. First, in the Sources panel, choose the well log alias or mnemonic. Then choose the wellbore interval for extraction to be made. Refer to the video help on creating zone intervals for help creating zones. Next, choose the well list for extraction. In the Settings panel, there are options for log sampling that can be chosen by the radial selections. Choose desired sources and settings and click Add to populate the results panel. Users can have multiple results in the Output panel. Use the pencil to adjust the name and description if necessary in the Scalar name column. Click Apply to run the extraction. Note, this extraction does take a while as the wizard is computing all the log data over the interval to one point. This is a great time to get up and grab a cup of coffee. The Data Generation Wizard, upon completion, will show a list of successful extractions, and those that the conditions for the extraction were not met. Click Export Summary to CSV to get the list of unsuccessful wells to investigate, and then when you're finished looking at these different lists, click Close when complete. These extracted attributes can be found under the wellbore interval the extraction was made in the data tree or in the well header in the zones folder listed in the wellbore interval selected. These data can be used in well data analysis and MvStats. Data Generation Wizard, create tops from horizon scalars. Maybe you don't have logs in every well contained in your seismic survey, but you've mapped a seismic horizon. Use the wizard to extract well tops from horizon surfaces. It will take the wells in a well list and attempt to intersect each wellbore from a horizon surface. Where the intersection exists, a well top will be created from the wellbore. Access the Data Generation Wizard and choose Create Tops from Horizon Scalars. Users will need horizons and surfaces and a well list containing the wells to find an intersection. Click Add and verify the top name and top color in the results panel at the bottom, and click the pencil to rename the new top. Once selections are complete, click Apply to complete the extraction. Users can put together multiple combinations of sources from the horizon surface panel, the well list panel, and then add to the results panel at the bottom. When you're ready, click Apply, and the extraction wizard will go through to create these tops for you. Once the extraction is complete, the wizard will generate a log to show which wells in the list were successfully created and which of those tops were unsuccessful and not created. Click through the list of successful and then conditions not met. Click the Export Summary to CSV to get a list of the unsuccessful wells to investigate further. And the new top will be found in the well header in the Wells under the Tops tab or listed as a top in the Well Tops list. Be sure to add this top to a well top alias if necessary.